I've been coding for a while now, and despite my best efforts and a lot of time and energy in pulling my hair out, I still write code with bugs, right? And I suspect that most of you do too. And even the people that get paid truckloads of money out in Silicon Valley, and I do mean truckloads of money, they still make bugs too. And what's the problem with bugs? Well, they lead to vulnerable software. Vulnerable software leads to attacks. Attacks lead to headlines and people getting really angry and upset, potentially even lots of user data being lost, and perhaps even lives being lost. Okay, so what I'm interested in is protecting software from attacks. So what's the solution? Well, you might say, let's write code without bugs. Okay, I don't know how to do that. I don't think anybody knows how to do that, honestly. And decades of experience suggests that maybe that's a really, really hard problem. So if we can't figure out how to write code without bugs, instead, we need a backup plan. Okay, and so the backup plan is where my current research interests lie. In particular, how do we take software, maybe an existing binary, existing piece of code, and add security guarantees on top of that? Okay, maybe how do you do this even without the participation or cooperation of the original software developer? Okay, that sounds great, but it turns out that's also a really hard problem. And it's hard for a couple of different reasons. One, defenses add overhead, and overhead might be unacceptable. Right? Software developers really care about their system performance, and a defense might double or even triple the amount of time it takes for their program to execute. The second is actually kind of the dirty little secret in the security community, and that's we don't know how to say whether or not a system is secure. We cannot quantitatively say that adding this defense is going to make our system secure. All we can settle for is these sort of lower guarantees, like the code is going to execute in a certain order, or this piece of memory can't be accessed by a certain process. And so those two challenges combined mean that we do the best we can, and we develop these defenses, and they're either not used or 6 months later they're broken, right? And there's some attack that gets around that defense. So we come up with another defense that fixes that attack or maybe lowers the performance cost, and then 6 months, a year later, they're broken. And so we're in this kind of arms race. And that's been going on for decades in the PC realm, but now it's moving on into the home. Right? You have these smart hubs, Alexa, you have smart thermostats, and believe it or not, and I'm not even kidding you, even my toothbrush has a Bluetooth connection. So now I have to worry about the software that is running on my toothbrush and whether that could be used to, I don't know, steal data from me or become exploited. Okay? So in a nutshell, my research is about taking software and making it more secure, doing low-level software defenses, even in challenging environments like how do you secure this toothbrush when it doesn't have an operating system and it doesn't have the same power and capabilities as a general purpose computer. Okay, so that's my research. Now, if you guys are interested in getting involved with that, there's 3 things you can do. First of all, come find me after this talk. I'll be out in the hallway. I'll be loitering in here. I'll be happy to talk with you and tell you in more detail what I've been doing. 2, in D-term, I'm teaching software security, and presumably I'll be teaching it next D-term as well. Take that course. It should be a lot of fun, though I suspect it's actually going to be really hard. So just know that going in, yeah. Okay, so you can take my course, or actually, once you've done those 2 things, and you're like, man, I can't get enough of this, right? Come do an independent study with me. I think this is an opportunity that the undergraduates don't take advantage of enough. Work with me on a project, something that's interesting for you. It takes the place of a class. You get course credit for it, and we get to do something that's really interesting and fun for both of us. Okay, so that's my pitch. Come find me afterwards, take my class, or do an independent study with me. All right, thanks, everyone.